Verify that 9 2/3 is a solution of the following system. Well, if you notice, I happen to have two equations and I have two different variables. Now, this ordered pair has 9 in the x spot. It has 2/3 in the y spot. Well, to verify, I am going to rewrite the equation so that where the x appears and where the y appears, I am going to put parentheses, which means this is 5 times 9 plus 6 times 2/3 equals 49. This was my y. This was my x. Well, the goal is, does the left side equal 49? Well, we have 4 times 5 is 45 plus, now, taking these two fractions, notice I can cross cancel to get 4. Notice this is 49. It equals 49. This is true. But notice I have a second equation. That means I'm going to take this 3, but I'm going to put 2/3 here because that's my y, minus a positive 9 is equal to -7. Well, when I cross cancel, these 3's are going to leave me with 2 minus 9 equals -7. This is true. Okay. Now, to have the ordered pair as a solution, it must make both equations true. If one equation is false, then it is not a solution of the system. So it's got to make both of them true. Notice I got a true here, I got a true here, then this 9 2/3 is a solution, but it must make both equations true. If you get one equation that's false, then it's not a solution. Okay? So notice this is another way of saying check my solution. Did 9 2/3 work? Well, the answer is yes. It makes both equations true. Now, we're going to look at a story problem, and we're going to look at its graph. And this is part of why I'm doing this section now, because some of you have started to work on your project and you have questions. Well, right here, this says, suppose you are considering which college to attend for a few summer classes. Now, College A, okay, College A charges $100 per credit hour and $400 in fees. College B charges $200 per credit hour, but has no fees. Now, vocabulary. Write a model. A model will be an equation. Okay. So we have college A and we have college B. Okay. Now we're going to write some equations. But notice they give me a little clue. They are telling me using H for the number of credit hours. Okay, college A, let's translate. College A charges $100 per. Now, per means multiply. So that means 100 times H and means add $400 in fees. That is my equation for college A. Now college B is saying $200, and notice the word per, that means multiply, but no fees. This is our model. College A is equal to $100 H plus 400. College B is 200. Now, if you had both of these equations and you needed to graph them, you got to put them on the same graph. And this is what's happening. Look at the graph of our two equations. Now, something that's not on the graph that you are going to need to know to do is that I have a red line and I have a blue line. But which college goes with the red line? Which college goes with the B line? Well, college A is the blue line. It's the blue line. This is my college A. The red line is college B. Now, remember what this little intersection meant? Remember the word break even? Okay. So if I take less than 4 units, and I'm going to say that's a 4, may not be right, but I'm saying it's 4. Remember, B would be cheaper. It's below the red line. It's below the blue line. But if I take more than 4 units, college A is the better choice. Remember reading the graph. Remember, this is my break even. This part right here, it's below the blue line. That means that college B is cheaper if I take less than 4 units. And I'm saying where the intersection is, it's 4. May not be 4, could be 3, but the intersection. But if I want to go more than that intersection, college A is cheaper. Notice at the 10 unit mark, and I'll make this right here. College A, if I want to take 10 units during the summer, is cheaper. Right? So what we've done in the past is now coming into play again. Break even, that's the intersection. Where is the better buy? Remember those words? Better buy. College A is cheaper, or College B is cheaper in the green area. College A in the yellow area is cheaper than College B. Stuff we've done in the past. Now, in this case, they are asking me to algebraically determine the number of credit hours for which the cost is the same. Now remember, for the cost, okay, for the cost to be the same, we are seeking the break-even point, which means I'm setting College A, which is, in this case, 100H plus 400 equal to College B's 400 equal to College B. This is College A. This is College B. Well, if I subtract 100 from 200, I get 400 is equal to 100H divided by 100. H is equal to 4, but the cost is taking this 4, and I got two places. I can either put it here or here. I'm still going to get a cost of $800. So where does the value appear on the graph? It's the break-even point. It is 4 units with a cost of $800. And remember I was saying it was 4? Well, I was kind of already telling you that the intersection is 4. But the cost was $800. Write a sentence when you would choose College A and when you would show College B. This is talking about break-even points, or what is the better buy. Remember that? College A is a better buy if I take more than 4 units during the summer. College B is a better buy if I take fewer than 4 units during the summer. We are talking about the better buy in this question. What is the better buy? Now, some of you may say, well, why don't they just say that? Well, they are, but you are having to understand and translate, what is this question asking? What is this question asking? Now, here's something that you might be interested in. Same story, but we're going to change the narrative a little bit. Okay, now, the graph shown below is considering two schools, okay, with the same tuition rate per hour. Now, same tuition rate. Now, explain when you would be less expensive. Now remember, the less expensive is the lower line. Okay, well, what is this graph showing? They have the same tuition rates. Well, if you'll notice, the blue line and the one I highlighted in green are parallel lines. And notice, what do these parallel lines on the graph indicate? Well, that is how we're going to explain it. Even though these two colleges have the same tuition rate per hour, each college has a different fee amount. Okay? They have to have different fee amounts. They have the same rate, but what does this mean without the story? Parallel lines have the same slope, but different y-intercepts. This is what they want you to take away from. Same slope. Remember, slope is a rate of change. Well, notice this lovely word, rate per hour. They have the same slope, but they have different y-intercepts. Okay, and to finish, the green highlighted line has lower fees. That's what it's wanting you to say. Why is one be less expensive than the other? The green highlighted line has lower fees. They have the same rate, but they have different fees. The fees are higher in the blue than they are in the highlighted green. But something you have to take away from this picture is right here. When you draw your graph, if the slopes are the same and they have different y-intercepts, you've got to have parallel lines. And there is no intersection with parallel lines. And that you've got to remember. Now, we're going to do something a little different. This is another part of the story, but they're going to change the scenario a little bit. Okay, the graph shows now. Notice the word. It's showing two schools. Now notice what it says. With the same tuition rate and the same fees. Now, I want to enhance this blue line by using my highlighter. I have two schools, okay? I have the green school. I have the hot pink school. They are sitting on top of each other. So what it looks like is that they are the same line. Okay. Now, what does this graph imply? And here's the catch about infinite solutions. Remember, infinite or many solutions to the system. Now I'm going to answer the question at the bottom. Why does the graph imply about infinite or many solutions to the system? This graph has two equations sitting atop of each other because the slopes are the same and the y-intercepts are the same. Two equations sitting on top of each other, and they have the same slope. Notice, same slope and the same y-intercept. This point here is the same y-intercept for both schools. Just notice we have two schools, but I'm only showing one line. I have two schools because they have the same y-intercept and the same slope. Now, explain when one would be less expensive than another. Both schools will always have the same costs. Therefore, neither school is less expensive than the other school. And that's what's happening. Same slope, same y-intercept. Now, the stories are to show you, just like your project may show you, that sometimes two lines are going to be parallel. Sometimes two lines are going to cross. Sometimes they're going to sit on top of each other. And that is what you're going to have to find in your project, except we're using three equations. Okay? Now, let's continue. Vocabulary. Now, a system of equations is a set of two or more. Your project's going to have more than two equations that need to be solved simultaneously. Now, we could run the numbers, which is something you're going to have to do, creating an Excel spreadsheet or a table. Now, if there are two equations with two unknowns, we call that a 2 by 2. Two equations, two variables. Now, could we get bigger? Oh yeah. We could have what they call a 2 by 3. Two equations, three variables. Well, we're not going to get those this semester. You go on in mathematics and we can have a 5 by 5, which means 5 equations, 5 variables. We can have a 12 by 12, and those are some of the systems that we put computers to. That is saying 12 equations, 12 variables. And that's a lot of variables and a lot of equations. But they all begin with how you learn to solve a 2 by 2. Because bigger systems like the 12 by 12, you need computers for. And if you're planning to take computer language, systems is something you need to understand. Now, a couple of things you need to know, and I have a table that should make life easy for you. Vocabulary. When a system has a solution, it is said to be a consistent set of systems or equations. When it does not have a solution, it is said to be inconsistent. Does not. Now, those are two vocabulary words. Consistent, solution. Inconsistent, no solution. Now, there's also two other words you have to know. When the equations in a system produce different graphs, they are independent. That means if we have two lines that intersect, we have two different graphs. If we have two parallel lines, they are independent. But if they're equivalent and produce the same graph, which means they sit on top of each other, they are dependent. And just as I told you, a solution is an ordered pair that satisfies each equation in the system, which means when you get an answer, it must make both equations true if you verify or check your answer. Now, this next slide you may want to print out because part of Pearson is going to ask you to use these four words: consistent, inconsistent, independent, dependent. And here we go. Now, I was very nice to give you a graph. Okay? That's going to happen sometimes. It makes it easier to understand. Now, notice row 1 below the graphs. Solution. The solution is that point of intersection. But notice B, parallel lines, no solution. Look at my C. This is two lines sitting on top of each other. So I am going to say infinitely many solutions. Now, look at the next row. Okay, this is going to talk about slopes. In A, we have different slopes. Slopes. In A, we have different slopes. In B, notice we have the same slope. In C, we have the same slope. Now look at the third line, the y-intercept. The y-intercept is this point and this point. Notice they're different. In the parallel lines, they're different. But if you look at C, they sit on top of each other. They have the same point. Now, here's the fun part. You want to know, is the system consistent or inconsistent? Now remember, consistent means I have a solution. Inconsistent, no solution. Well, I have a solution. That's that green dot. But parallel, there is no solution. So it's inconsistent. consistent. But if you look at the line on top of each other, they have a solution, but they have a lot of solutions, many solutions. Now, independent and dependent. The graphs. The two graphs in A are independent because they're different. One goes up, one goes down. I still am independent with parallel lines. But notice when a line sits on top of each other, they are the same line, and therefore they are dependent. Vocabulary words. Keep these in mind. Now, the rest of the slides are going to do two things. We are going to find the solution by graphing the next couple of equations. Now, I'm going to let you know that graphing is normally the longest way, and it's not the most accurate way to get a solution. But we still have to graph them, and we have to figure out the intersection of the lines. That's my solution. Then we're going to do the first or the second of three methods to solve a solution. The second method is known as substitution. Now this is a lot of algebra, but it gets us to a more accurate answer than the graphing. Now let's show you. I'm giving you a series of steps. It says graph both equations. Now, how you graph is going to be up to you. You can plot points, but remember, your graphing tool will take 2 points, and then you have to check a third. You could also use the slope-intercept form, which I'm probably going to do with these equations because it makes it easier. Now, this third step is asking you to verify the solution. That's going to be your choice. Sometimes you can verify it, but not all the time can you truly know the solution because it's not the most accurate place on a graph. Because if it falls between some boxes, how do you know what's the correct solution? You won't. You would have to guess. And guessing says this is not the most accurate. Now, we're going to do a couple of graphs. Right here is my first one. Now, it is saying y is equal to x. Well, for question A, my slope, remember that letter M, is 1. My y-intercept is 0, 0. Plot this point right here. That's right there. That's my black dot. Now, my slope is a positive 1 over a positive 1. Well, that's going to give me here. Well, notice that's sending my graph in this direction. But I've got to look at the slope that goes the opposite, which means my slope is a negative 1 over negative 1. I change the sign. That's going to give me a point right here, which means that goes there. I have to go right of this point. That's my y-intercept. The black takes me right, the red takes me left of the black point. Now, this one. Okay, my slope is going to be a positive 2 over positive 3. That's what this fraction is saying. My y-intercept is 0, negative 2, which means that my dot, my blue dot, is right here. I'm graphing this point first. Now from that blue dot, I am going to go up to right 3. That means my graph is going this way. But don't forget, this slope is also a negative 2 over negative 3, which means from this blue dot, I'm going down to 3. There's my red, my orange part. This is sending me in the orange. This is sending me in the green. One is going right, one is going left. Okay. Now, if you look at this particular graph, this is where you're going to have to be very, very, very careful. Now, your graphing tool is going to be more exact than what I did. I plotted 2 points. I went from the y-intercept up, the y-intercept down. Well, if I had graphed this better, then I should have probably been more accurate. Okay. I'm going to put the red one. That's the better, more accurate red one. And then this is the more accurate orange one. Okay. The reason I'm doing that is I have something right here. This point, when I accurately graph the 2 lines, is going to be negative 6, negative 6. Well, to make my point, graphing isn't very accurate. Notice I had to fix my red and my green line. Well, that's going to happen sometimes, but with Pearson, they're going to draw your line pretty good. Because when you take 2 points, they're not going to care about going the red or the orange. They're just going to, when you put the black on, your tool is going to automatically draw the line. When you do the green, it's going to automatically put the green line. This, I will let you know, is my solution. And remember, I can verify this. And that's what you're going to do, or try to do, by using these 2 equations. You're going to put negative 6 in for x, and you are going to put a negative 6 in for y. We're going to verify. Remember what we did? And negative 6 and negative 6 will make both equations true. That's why we can find the intersection very easily. Now, if you need, blow up the graph so that you can find this negative 6, 6 a lot easier. Use the little circle with the plus inside so that you can more easily find the intersection. Okay? Now, that's one equation. Now, right away, this is going to be a little harder. Okay, it says solve the system. We've got a graph. You want to take the top equation and the bottom equation. Solve them for y, which means the A equation is going to be 2x plus 8 is equal to y, is equal to 4y. Divide by 4 to get 1/2 x plus 2 is equal to y. This is my A equation. Now, the B equation, 5x. Now notice I'm adding 6y to both sides because when I divide by 6, I get 5, 6x. 6x. Well, take this equation. A has a slope of 1/2 and a y-intercept of 0, 2, which means I'm going to put my point right there. That's my y-intercept, and I am going up 1 over 2, which is right there. Right there. That's my point. Up 1 over 2, up 1 over 2. Now notice, I'm using this slope to take me in this direction. Now remember, I want to use the opposite, which means my slope that's going to take me to the left is -1, -2, -1, -2, -2, which means I'm going in this direction. I have to go right, I have to go left. Now, B, my slope is 5 6ths. My y-intercept is 0, 0, which means I'm going right here. That's my 0, 0. Now, from this green part, I'm going up 5. Oh, look at what I got. I'm going in this direction. If I go and take the opposite, which is a -5 over -6, down 5 over 6, I go this way. But this is my intersection. My intersection or solution is 6, 5. If I can go back up here put x for 6 and y for 5, I can verify this solution. Okay. Now, let's look at this one. Okay, this is equation A. This is equation B. First step, take A and solve for y, which is 2y is equal to negative 3x minus 7. Divide by 2. Okay. Now, take your B equation. Now this is negative y is equal to negative x plus 1. Divide by negative 1. This is my equation. Now, the hot pink has a slope of positive 1 over positive 1 and a y-intercept of 0, negative 1, which is that dot right there. Up 1 over 1 is going to give me, in this case, right up here, right here, I am going in this direction. But remember, what's the opposite? Down 1, left 1. Down 1, left 1. Which means I'm going in this direction. I have to go right and I have to go left of this point. Now, I'm going to be honest. This one, the A equation, is not very nice. The A equation has a slope. Now, notice I have a negative here. This will be negative 3 over positive 2 with 0. Now, it's negative. Make this into a decimal, 3.5. Why is 3.5 better? Because I can easily find the 0, 3.5. Now, from here, I am going down 3, up 2. Down 3, which means I'm going in the middle, because this is a little bit above 4. And I'm going to show you what I mean. Make the graph a little bigger. Okay. I'm going to go down 3, which means this is 1. Don't make that big. Okay. This is 1, 2, 3. And I'm going right 2, which is right here. I'm going down on the graph this time. Well, this slope has to be done the opposite, which means I'm going has to be done the opposite, which means I'm going up 3, left 2. I have to do the opposite, which means I'm going 1, 2, 3, and then I go left 2, which is right about there. Okay. Now, notice what happens. Now, this one is my intersection. Now, sometimes it's very easy to see. Sometimes it's not. This one, we can try and read it and believe that it's -1, -2. Because that's what it looks like. But the only way I can verify this solution is to come back up here and put it into the equation. It's sometimes hard to truly see if that's the solution. Okay? Now, the last one. Okay. First step. This is equation A. This is equation B. Solve for y. For y is equal to a positive 3x plus 12. Y is equal to 3/4 x plus 3. This is my equation for A. Well, let's look at B. Negative hy is equal to -6x minus 24. Now notice what happens when I divide everything by -8. I get y is equal to 3/4 x plus 3. Look at these two equations. They're the same, which means I'm really drawing from this dot, which is 0, 3, my y-intercept. I'm going up 3, 1, 2, 3, 4, right here. Down 3, down 4, down 3, 4, going this way. But the beautiful part is that this is one line atop of another line. They're sitting right on top of each other. Same slope, same y-intercept. Now, the solution is many solutions, or what they call infinitely many solutions. Okay? Now, this is graphic. Now, this is the second method. It's called substitution. Now, this is a lot of steps. Algebraically, it is a lot of steps. But it's easier to show you than it is to give you this slide. But for those of you who need this slide, this is here. Now, when we work with this, we want to find what they call a home equation. Just like anything in the world, we start at home, we leave our house, we go do a whole bunch of things, but we return at night to our home. Well, this is the process that's being applied to algebra. I start at my home. I go to school, to the grocery store, to the post office, wherever I want to go when I leave the house. But at night, where do I return? My home. Now, the home equation must have one variable, and it can be x or it can be y by itself. And it must have a coefficient of 1. Now, if there's no equation with a variable all by itself and a coefficient of 1, I have to make the equation my home equation. I have to make it, which means I got to do a little algebra before I start. Then I'm going to do what this process calls for. I'm going to substitute my home into the other equation. And then I am going to solve for the variable that remains. And you're going to see what I mean, but I have two variables. I'm going to get a variable up through step 3, but this is where we return home. You're then going to substitute the value you got in 3 back in your home. And then that is going to give you your answer. But remember, it's your choice to verify. And the key is to verify in the non-home equation. Now, this is a lot of work, but let's do it together. It's not as bad as it is. Let's look right here. Now, notice the instructions. Solve by substitution. Well, the first thing I want to do is to find a home equation. Well, if you look at the very first equation, notice that I have the y all by itself on one side of the equation, and it has a coefficient of 1. This means that y equals 2x plus 4 is my home equation. Very nicely done. Now, what do we do with the home? Well, what we're going to do is take this green part of the home and put it in where y appears in the second equation. But how do I do that? I take the 3. Now where that y is, I'm going to put a parenthesis. And inside that parenthesis, I'm putting 2x plus 4 equals 6x plus 12. I just substituted this green part went into the non-home equation. Went into the non-home equation. Well, this is going to give me 6x plus 12 equals 6x plus 12. Okay. What do these left side and right side mean? Remember, they're the same. If the left side is the same as the right side, I have many solutions. Remember, that was the algebra we learned earlier. If the left side is the same as the right side, I don't have to do any more algebra work. That's my answer is the words many solutions or infinitely many solutions. The left side is the same as the right side. That's a lot less work than graphing. And well, Well, let's look at this one. Let's get a little different here. Okay, now, the first equation says, because I'm solving by substitution, says 3x plus 2 equals 7. But look at my second equation. It has x all by itself. The second equation is my home equation because I have this x all by itself. Well, now, what am I going to do? I am going to take this y plus 11 and put it where x is in the first equation, which means I have 3 y plus 1 plus 2y equals negative 7. I just substituted. My x was equal to y plus 1. So where this x was, I put y plus 1. Now we're going to solve. This is 3y plus 3 plus 2y equals negative 7. Well, this is going to give me 5y is equal to negative 10. Okay, this is different than the one before because when I divide by 5, I get a y value of negative 2. But this is where the substitution comes with. I'm taking this y is equal to negative 2, and I'm going to return home. Where this y is, I'm going to write x equals negative 2 plus 1. Find x, which is negative 1. I return home. I got a value for y. It wasn't like the slide before where the left side was equal to the right side. But how do I write my answer? You've got to put it in an ordered pair. My answer is negative 1, negative 2. The x goes first, the y goes second. This is my answer. Now, if I want to check it, and I'm going to show you what I mean by check. Check means 3 times negative 1 plus 2 times negative 2 better equal negative 7. I'm using my non-home row. 3 times negative 1, 2 times negative 2 gives me negative 7. That means that this solution of negative 1, negative 2 is correct. Let's try this one. Okay, this is getting more interesting. If I look at either the A equation or the B equation, I do not have a variable by itself. Well, if you look at the top equation, this y has a positive 1 coefficient. I can make this equation my home. But how do I make it my home? I subtract 2x from both sides. I make this equation, the first one, because y is by itself. Now, I don't want to look at the 4x and 7y, because I'm going to get lots of fractions. Don't want that. But I have a y that has a positive 1 coefficient. Can I make that positive y by itself? Yes. Now, the minute I do that, I no longer look at this equation. This equation is my home, which means that negative 2x is going to go in where this y is, which means I'm going to write 4x plus 7. Now, inside the parentheses, I'm writing negative 2x is equal to 20. 4x minus 14x is equal to 20. Negative 10x is equal to 20. When I divide by negative 10, I get an x value. But I return to this home. I return home to find y. Y is equal to negative 2 times negative 2, because this x is negative 2 times negative 2, because this x is negative 2, means that y is a positive 4. My answer is negative 2, positive 4. But remember, we can check it. Now this is your choice. If I check it, I am going to write 4 parentheses, negative 2 plus 7 times 4, and this had better give me 20. This is my check. I take this equation and I put in the value for x and the value for y. This was my x, this was my y, and this equation is true. Okay? Now, here we go. This one is not a nice one because you need to choose an equation to be your home equation. Now, some people like to play around with both equations to see which is easier to make it their home. Now, I'm going to tell you that if you took this one, 5x minus 6y equals 0, that equation would give you fractions. Because if you isolate x, you would have x is equal to a positive 6 over 5y. If you isolate the y value, you would have a fraction. So therefore, we don't want to use the 5x minus 6y equals 0. But if you look at the first equation, now I have 2x by itself. The 4y minus 8 is on the other side. But if I divide every term by 2, I would get x is equal to 2y minus 4. Look at this equation. it has no fractions. So therefore, I'm not looking at this yellow equation anymore. This is my home equation without fractions. Okay? So now, what am I going to do? This is my x. This is my x. I'm going to put in what is not the fraction. This is going to give me 5 parentheses 2y minus 4 minus 6y equals 0. This equation, you don't want to make your home. You want an equation that has a variable by itself, but avoid having fractions. Now, could you use fractions? Oh, yeah, but then you have to do the rest of this problem using fractions, and that's not always nice. This will give me 10y minus 20 minus 6y is 0. 4y, now I'm going to add 20 to both sides and divide by 4. Notice I have a very nice number. Now, return home, which means where this y appears, right here. I am going to have x equals 2 times 5 minus 4. X is equal to 10 minus 4, or x is equal to 6. My answer is 6, 5. Now remember, if you want to check it, okay, you would then take 5 times 6 minus 6 times 5 and see if it equals 0. And it does. And notice I did this entire problem without fractions. That is the whole part that you have to watch out for. Fractions. If I can avoid it, don't use fractions. Now, sometimes you have no choice. But if you have a choice, find the equation in the system where there are no fractions. Now, we are going to be doing the last part of this lesson, and it uses story problems. They are systems, okay? Now, they are also going to use the method of substitution. Now, here we go. You need to translate this very carefully, okay? Now, it says, Emily is working as a nutritionist to design a more healthful meal plan. She is advised to aim for 1,200 calories per day with, now here comes some math words, twice as many calories coming from carbohydrates as from proteins. She wants between 30 and 60 grams of fat. Now, she is deciding to eat 40 grams of fat. Okay? She's deciding to equal 40 grams of fat. Now, how many grams of proteins should she have each day? Now, she knows that her total calories come from carbohydrates, protein, and fats. Now, write a 2 by 2 equation and solve it. Okay, this is a lot of words, a lot of translations. Now, we are going to take the first part of this. It says with twice as many calories from carbohydrates as proteins. This phrase that I kind of boxed in is a equation. Yeah, you kind of figure it out. Twice as many calories coming from carbohydrates as per proteins. Well, this is where we're going to do a little bit of work. C equals carbohydrates. P equals proteins. And F will equal fats. But the nice part about the F is that we are told right here. She's choosing to eat 40 grams of fat per day. So technically, we're getting rid of this variable. That's why we have a 2 by 2. But let's take that sentence that I kind of marked off in black. Now, this is where you have to be careful. We have a series of words. As many as. That phrasing in mathematics, as many as, has the word carbohydrates between those two highlighted words, which means the carbohydrates is equal to twice as many proteins. The phrase as many as is talking about carbohydrates. We have twice from proteins. Twice from proteins. That's why it's 2p. The noun between the phrasing as many and the word as is carbohydrates. That's the C. That is our first equation. Now, we notice that fats, she's made a choice. So our fats are going to be 40 grams. Okay, we know that. Now, we need a second equation. This is where the word total calories comes into play. Total means we're adding, but there's a little catch with that add. We are told that total calories comes from fats, but it's 9 calories per gram. This slash means per. So this slash means per. So the total is equal to 9 calories per fats plus carbohydrates, 4 calories per gram. So this is 4 C. Proteins is going to be 4P. And this T is our 1200. That's the total number of calories she's going to have. Total means I'm adding, which means this is 1200. Okay. Well, how does substitution work here? Well, notice this C represents this C. I am going to have the equation of 1200 equals 3600 plus 4 times 2P plus 4P. 360 comes from this phrase, 9 calories per gram. Well, we're already told that we're eating 40 grams of fat. That takes care of one of the variables. This C is replaced right here by 2P. And there's my 4P. What I then am going to do is combine terms. 1200 is equal to 3600 plus 8P plus 4P. 1200 equals 360 plus 12P. I'm solving this equation for P. Well, if I take 1200 and I subtract 360, I get 840 is equal to 12P. Divide by 12, and that means I am going to have 70 grams of protein. But don't forget, I've got to return home to find the C, which means my carbohydrates is equal to 2 times 70, or 140 grams of carbohydrates. This is my equation. Now, some of you are going to find this very easy to do. Some of you are not. Take the pieces. You know the word total means I got to add. Well, what am I adding in that sentence? Carbohydrates, protein, fats. I have a total of 1200 calories. Now that phrasing, as many as, you got to watch out for that. That's one that's part of many story problems. The noun between the words as many as. Now we have a lot more words between as many as, but we have a noun. That noun is carbohydrates. And that means carbohydrates is being defined in terms of protein. Now, let's take a look at this one. Okay, this one, not a nice one. Okay, but it's really quite simple. Okay, first off, we are being told that we have a baseball game. A baseball team has home games on Friday and Saturday. Notice those are two nouns. The two games together earn $5,264 for the team. Now, Friday's game generates, now watch this, less than Sunday's game. Okay. How much money was given at each game? Okay. The key is, what are the nouns? F will equal Friday and S will equal Sunday. Those are our nouns. Now, translate. We are telling you two games together. This is saying I'm adding those two games. That's what the two games mean. Together is saying Friday plus Saturday equals $5,264. That's what this first sentence means. Now, next sentence. Okay, we got to translate this one. This is saying Friday's game, which is F, generates. This is a verb. Let's see that word less than? Less than means $1,136 is being placed behind the minus sign. Less than, we write from left to right. Well, notice this F is all by itself. This amount is going in for my F. I'm substituting. I have F minus $1,136 plus S is equal to $5,264. These two S's give me 2S. I am adding 1136 to both sides to give me 0,046 divided by 2. Now S is Sunday's gain, which is $3,220. That's how much is earned for Sunday. But how do we find Friday? You return home. Where this S is, you are going to put in 3,200 minus 1136. 1136. And if I take 3,600 and minus, or 3,200 and subtract 1136, Friday's gain will give me $2,064. Now, here's something really nice. If I take this amount and I take this amount, what do you think it's got to equal? $5,264. This is a way of checking. It's a way of checking. Now, my last story problem. Okay. Now, again, we are using substitution, and we are going to look for nouns. A, here we go, rapper and a reggae band. Those are our nouns, are going on a concert tour. Okay, here's another math word. Together. The rapper and reggae band visited 178 cities. Together. That means we're adding how many concerts the rapper and the reggae band did. They visited together 178 cities. Now here comes the good one. The rapper visited 94 more than the reggae band. Now, they're asking you two questions here, which means I definitely need two answers. How many cities during the concert tour did the rapper visit? How many cities during the concert tour did the reggae band visit? Okay, what are our nouns? W is equal to the rapper, and R is equal to the reggae band. Notice how I'm using the first letter of each noun. Reggae, rapper. Now that's the first sentence, the ones highlighted in yellow. They are our nouns. Now the second sentence, together. Well, together means I'm translating. Together means the reggae and the rapper visited 178 cities. Two variables, one equation so far. Now, the hot pink says the rapper visited. Okay, more than is plus, but the 94 goes behind the plus. The noun after the word more than is reggae. I have my system. This W is going to be substituted into this equation, which means R plus 94 plus R is equal to 178. I'm using this equation as my home. 2R. Now, subtract 94 from 178, and I get 84. R is the reggae band. They visited 42 cities. But don't forget, this means I return home. And where this R is, I am putting the 42. So W is equal to 42 plus 94, or the rapper toured, in this case, 136 cities. These are my two answers. This one and this one. This ends this section of 315. Enjoy.